Welcome back, everybody. We're now going to look at the solutions for the new Now You Try problems on finding the domain and range of a function that is given graphically. The instructions say to give the functions in the attached image, determine their domain and range. See, I'm assuming I know what it says and I'm not actually reading. Don't do that. When you're doing problems, read the instructions carefully. All right, let's zoom in on part A. Here we have a function named f, and it's just 3 points, so there's nothing else to this function. The 3 points are the points -3, -2, 0, -1, and the point 4, 5. So the possible inputs are just the x values of these points. So the domain equals the set including -3, 0, and 4. The range is the possible outputs of this function. Here we have the y values of -2, -1, and 5. And so that will tell us the range. The range equals the set of possible outputs being -2, -1, and +5. All right, let's just hurry on down to part B here. Here we have a downward facing parabola. It has a vertex at the point 1, 2 that's included as part of this function. And then it keeps going down for forever in both the left and right directions. There's no end points to this parabola. It's continuing on for forever. To the left, downward, and to the right, downward. So let's look at the domain first. If I take this and think about what x values can we plug in. If I start from that vertex and move left, I can keep moving left for forever and I don't skip anything. If I start from the vertex and move right, I can continue to the right for forever without skipping anything. So this domain is the set of all real numbers, including everything from -infinity to +infinity. The range is going to be a little bit more complicated here. Not too bad, but a little bit. We see that the range has a high point, that this graph keeps on going down for forever, right? If I move to the left or to the right from the vertex, we keep going down in both directions without skipping anything. But the high point is the vertex at 1, 2. If I took this and smashed it onto the y-axis, I would see that the highest y value I get is 2. And everything else just keeps going down without skipping anything. So that means the range is -infinity up to 2, including 2, without skipping anything else. All right, that's it for part B. That's all we're doing. There's not really any work to show. Let's go to part C. Here we've got a straight line. Starts in the upper left at the point -2, 3, and it goes down to the right to the point 3, -3. Straight line, no breaks in it, no curves, nothing, just perfectly straight from the point -2, 3 to the point in the bottom right of 3, -3. Those are open circles at the endpoint, so we're not including those. So if I look for the domain starts at -2, but not including -2. I do parentheses -2, and I go comma 3. Note that this is an interval, not a point. Okay. If we'd taken this and smashed it down onto the x-axis, we'd have an open circle at -2, and then the right end point, 3, -3, would come up to an x value of 3 on the x-axis, and we get everything in between. So we get all the x values from -2 to +3. The outputs, on the other hand, it looks like we have a maximum output of 3 at the top left and a minimum output of -3 at the bottom right, except for we, again, don't get to include those values because of the open circles. So we want to write this from the smallest number, the -3, up to the biggest y value of +3. So kind of writing it in the opposite order of how it looks on the graph, so that we're doing small y value to big y value. If I took these points and I smashed them onto the y-axis, I would get a low y value of -3 at the bottom and a high y value of +3 at the top. And so we get that interval for the range of -3 to +3. All right, one last one for these now U-try problems. Here, for part D, we have a function g of x, and it is an upward-facing parabola with a vertex, in the label, at the point -1, -1. It is cut off, so it's upward-facing. It has a vertex at -1, -1, and then it goes up to the left for forever, and it looks like it hits this point along the way. So it does keep going with an up arrow, but it does hit the point -3, 5 along the way. And then on the right side from the vertex, as it goes up and to the right, it stops at the point 0, 1, and we do include that point 0, 1 as part of the graph. It's a closed circle, not an open circle. So if I am looking for the domain of this function, it's going to be all the numbers. So this, if I move from the closed circle at the point 0, 1, the farthest right that we can get is the number 0. And then if I think from here, can I keep moving to the left? Are there any breaks, or does it ever stop? And the answer is no. This keeps going left for forever. So the domain is -infinity all the way up to 0, including 0. The range is all the possible outputs, all the y values that this graph takes on. So if we say, what's the smallest y value? The smallest y value that we can get out is the number -1, and we can get that out. That's at the vertex, -1, -1. And then from the vertex, whether I go to the right, well, if I go to the right, it's going to stop at an output of 1. But if I go to the left, it never stops. It just keeps going up and up and up for forever. So the question is, does the range stop at 1 or does it not stop at 1? Well, if we can get an output bigger than 1 at all, it doesn't matter if it's on the left or right, that is included in the range. If I took this line and smashed everything onto the y-axis, we'd get the smallest y value at -1. And then the stuff down here between -1 and +1 would smash twice, but it would just show up once in the range, and then this does just keep going up and up for forever. So the range is -1 to infinity, excluding infinity, but including -1. All right, I hope that was helpful, everybody. Thank you for watching, and we will see you in the next video.